36 in our review of confidence intervals and hypothesis test. In a random sample of males, it was found that 24 write with their left hands and 216 do not. In a random sample of females, it was found that 64 write with their left hands and 453 do not. Use a significance level alpha of 0.01 to test the claim that the rate of left-handedness among males is less than that among females. So here, I want to argue that the proportion of males that are left-handed is less than the proportion of females that are left-handed. So if the first population is male and the second is female, option D is my choice. Now I need the test statistic and the p-value to continue. So in order to calculate this, I'm going to open up StatCrunch. And I'm going to do a 2 proportion test. So I'm going to go stat, proportion stats, 2 sample, and here I have the summary data. So entering the summary statistics, how many left-handed men do I have? There's 24. And how many men were sampled? Well, this is a little tricky because I've got 24 that write left-handed and the others do not. So the total number sampled, if I add those two numbers together, is 240. So 216 plus 24 is 240. And for the females, the second population, there were 64 that wrote left-handed, but there were 64 that wrote left-handed, 453 that do not. So if I add those together, what do I get? I believe that is 517. Maybe check that real fast in my head. Okay, so we're going to use a 1% significance level to reach this test. So state the hypotheses. Remember that P1 is equal to P2, so the difference would be 0. I'm not trying to argue that they're different. I'm actually trying to show what? Less than. If the male proportion is less than the female proportion, this would be a negative value. Okay, so I'm going to compute. And so in my table, it's going to give me several values. But over here, it's going to give me the test statistic. That's the z value. And so in this case, rounded to 2 decimal places, this is negative 0.95. And then the p-value shows up as 0.171, rounded to 3 decimal places. And so now, since I was using a significance level of 0.01, the p-value definitely is greater than the significance level. So we're not going to reject. We failed to reject the null hypothesis. Thus, there is not sufficient evidence to support the claim that males have a lesser rate of left-handedness than females. In part B, it says test the claim by constructing an appropriate confidence interval. So if I wanted a 1% significance on a one-tailed test, in order to construct a confidence interval that has 2 tails, I would need to have 1% in each of the tails. So here I'm looking for a confidence interval of 98%. So I take the 1 minus the significance level twice. So what I can do over here, if you want, you can just press Options, Edit, and change your hypothesis test to a confidence interval and choose the appropriate confidence level, in this case 98%, and press Compute, and it will give you the lower limit and the upper limit. And so if I look at this to 3 decimal places, the lower limit is negative 0.08. The upper limit to 3 decimal places would be 0.032. And so interpreting this, because the confidence interval limits actually include 0, then it is possible that the difference is 0, making them equal. So it appears that the two rates of left-handedness are equal, or at least could be. There is not sufficient evidence to claim that the rate for males is less than females. So that's just another way of conducting the test, but using a confidence interval to reach that conclusion. I hope this helps.